So in class we discuss resistance, okay, R, the measure in ohms. And so here I have components that we call the resistors. I have 5 ohm resistor, 10 ohms, 15 ohms, and 20 ohms. Okay, so first of all, you see I have my circuit. So the current is flowing from the plus through the resistor, through the light bulb, into my multimeter so I can measure the current and back to the battery. Okay, so it's like now I have two loads. One load turn energy into light and some heat, and this load, which purpose is to decrease the current, turn that energy into heat, and I can touch it, and it's getting very hot. It's not very happy here, so I'm not going to let that happen for too long. But you can measure the current here, and it's 0.28 amps. Okay, 0.28 amps, and the light bulb is quite happy. So now I'm gonna multiply the resistance by 2. Okay, here the resistor by 2. So the total resistance, you will have to add the resistance from the light bulb plus the resistance from the resistor. But here, just multiplying by 2, let's see what's going to happen with the current. So before it was 1.28, and now it's going to decrease 0.22. So 0.22 amps with 10 ohms here. Okay, so the goal is to see that as you increase the resistance of those components here, they are called resistors. You can find the resistance here by looking at the colors. You're going to decrease the current even more. Now, increasing the resistance even more, I have 15 ohm. So you see the light bulb seems to complain a bit. It's not as bright. And the current is decreasing even more, right? It's 0.18 amps. Okay, 0.18, about 0.20 actually, 0.20 amps. And now I increase even more the resistance of the resistor. So it's good, it's not that hot anymore. So you see the light bulb is definitively not very happy. It doesn't get enough current because the current has been decreased by the resistor. I have 20 ohms, and here it says 0.16 or 0.18, 0.18, about 0.18 amps. Okay, so that's how it works. Now, what happens if you change the resistance? So you decrease the current, but there is something else happening, is that higher is the resistance that you use here, more voltage drop across that will happen. So let me see. So here, this is my voltmeter. Okay, I want to measure voltage. Okay, so I'm measuring the voltage across the power supply, and you see I get 4.2 volt. Across the light bulb, I get 0.76 volt. Okay, so it's not very happy. It's happy when it has about 3 volt. So now it's not very happy, 0.76. And across the resistor, it says 3 volt. So it means that the resistor is stealing most of the voltage. The light bulb has a small resistor inside. It's not like it's a resistor inside, but it has its own resistance. But that resistance is very small. It's about 5 ohms. so it doesn't get enough voltage across, because the voltage is proportional to the resistance. So Ri. Okay, so this one has a high resistance, it's going to take most of the voltage. So if you decrease the resistance here, so not only the current will increase, so it's up here, but also you see you don't have that much voltage. Now I have a voltage of 2 volt. Okay, so 2 volt, and this one also has more voltage, 1.5 volts, 1.5 volt and then 2 volt. So the effect of adding resistor is you decrease the current and you have more voltage drop across it. So if I decrease the resistance again, so now I'm 5 ohms, I should not do that too long because it gets very hot. So now it's very happy. Okay, so what's going to be the voltage across it? It's about 2.3 volt. And here it's going to be 1.36. Okay, because the resistor here is small. This one should be larger than 5 ohms. Okay, but it gets very hot, it can melt, so you have to be careful. Okay, so here I had a voltage of 2 volt, and here I had a voltage of 1.5. So the resistance here should be between 5 and 10. Okay, now if I take 2 light bulbs of about the same, and they both have the same resistance. So if I take 2 light bulbs, same resistance here. So here you have a happy light bulb, it's very bright. Now if I put 2 light bulbs, do you see? Let's say they have the same resistance. That means if you have 2 light bulbs, the current will be divided by 2, and the voltage across them will also be divided by 2. So if the current is divided by 2, the voltage is divided by 2 for each load, that means it will get half the energy it's supposed to get. Okay, let's measure the voltage here. So the voltage here is about 1.7 volt, and here it's about 2. So they are not totally equal. So this one is 2 volt, that means it has more resistance. Okay, so this is called the circuit in series.